There we go. All right. So we've been talking about how do cells divide. So let me get in here. There we go. All right. So yesterday we got started talking about the different stages of cell division. So the first stage we talked about was interphase. There. Now, interphase is what I like to call the preparation phase. It's kind of what I'm doing tonight is my cellular interphase, where we're getting everything prepped for the big day tomorrow. We're getting everything, like we've got the turkey, we brine our turkey. So we've got the brine that was cooked yesterday. We're going to brine it overnight. So it's all of the preparations that have to happen during interphase. There's no actual division going on during this phase. We're just getting all of the preparations out of the way. And I'm not even on the right slide, am I? There we go.
I was kind of wondering.
Why did you not say anything?
As you're the teacher and I wasn't going to correct you.
Oh, no, you correct me anytime. Anytime I'm doing something,
I was so confused too.
You correct me anytime. All right, here we're on the right slide. Interphase. Now, we talked yesterday about how originally we called this the resting phase, but we know that cells are never truly at rest. They're either dividing or they are not dividing. And when they're not dividing, they're still doing their little cell job. Like my liver cells are still working, even though they're not maybe replicating. So now we don't call it the resting phase anymore. We call this the metabolic phase, which simply is a fancy word for not dividing. That's it. We got two roles in this cell's life: dividing, not dividing. And here we're not dividing, we're just preparing. So what is happening during this interphase? Well, the first thing we've got to do before we can make a brand new cell is we've got to carbon copy our DNA. We need to make a copy so that we can have one full strand of DNA in the first cell and a brand new strand for the new cell. Because remember, DNA is the blueprint. It's how is this cell acting? What does it do? What is its job? How does it interact with its environment? All of the above. And so we've got to give the new cell the kind of right foot to start off on and give it a shiny brand new strand of DNA. So that's what's happening in this phase. We are replicating the DNA in preparation. We have this thing called a helicase. Helicase is an enzyme. In fact, anytime you use the suffix ase, it's usually referring to an enzyme. Enzyme is just something in your body that does something else. Helicase is the enzyme that pulls apart the DNA, right? Because we've got our DNA strand, and we've got to pull it apart into two and then rebuild. So helicase is what pulls it apart. Polymerase is what builds it back up and attaches our nucleotides so that we have two carbon copies of the same DNA. We talked a little bit yesterday about the leading strand and the lagging strand. So when I am unzipping my DNA, there's a very specific way that I have to reassemble it. Specific direction. One direction, actually I've got a picture here, that would be easier. I'll go back to this in a second. So, where is it? Here we go. So one direction, here I have, so I'm unzipping, right? Everyone sees that. I'm unzipping it. And I have this strand, which is being reassembled in this direction. So you see that I can add my nucleotides as it's unzipping. Does everyone see that? This strand, on the other hand, has to be assembled in the opposite direction. So I am reassembling, reassembling, reassembling. Then I got to go back, reassemble, 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 go back. And so I have this kind of stutter because of the direction I have to reassemble it. That's why this is called the lagging strand, because I have to keep going back. I'm kind of assembling it in a backwards motion. So the leading strand is nice and continuous, and my lagging strand going this way, I am making, but then I run out because I'm already at the point where I made it before. And then I make, make. Does that make sense? I have a little video that I'm going to show you. I know I started showing you a video yesterday. I found a better one because I realized that when they're going in the 3 to 5 and the 5 to 3 and no, that was far too much information for what we need. I just simply want you to know